Algebra 1, Day 12. Today we're going to talk about graphing linear functions. But before we actually get into the notes for today, I kind of want to go and take a step back, and I want to make this as simple as possible. So, I'm going to do this in a very, very basic manner, so please just bear with me. First thing, whenever I'm graphing anything, doesn't matter what it is, I always have two axes. I have my range, or my y-axis, and I also have my domain, or my x-axis, right? We can also call this input, independent variable, right? And over here for the range, we can also call this output and dependent. So, different lines can look many different ways. We can have a line that looks like this, like this, like this, like this, any number of different things, okay? However, all of them share very interesting features in common. For any line, you should be able to write the equation y equals mx plus b. Okay? This is what's called my slope. This is what's called my y-intercept. That's why it's called slope-intercept form. So, anytime you hear the word intercept, that means that where it touches something else. Okay? So, before I get into that, let me take another step out, and I'm going to tell you about the different types of slope. There are 4. So imagine that each one of these is a graph. Okay. Those purplish pink lines are going to be my 4 different kinds of slope. There's positive, negative, 0, and undefined. Okay? Positive slope, y equals mx plus b. Negative slope, y equals mx plus b. 0 slope, y equals b. Also written as y equals 0 times x plus b. Undefined, x equals a number. Okay, so 4 different kinds of slope, pretty simple. If you notice, feature over here, on this side it's higher, so it's positive. On this side it's higher, it's negative. This is flat across, so it's 0. This is straight down, undefined. Okay? So, now that we kind of understand a little bit about the slope, let me just get this out of the way, give us a little bit more room. Okay? So, now that we understand a little bit more about the slope, what I want to do is I'm going to draw a line. Now, it obviously does not matter where the line is, what's going on, anything like that. All we're talking about is just the features. So don't pay attention to the slope or anything else, just the features of the line. Okay? So, here on this line, I have a point where it's going to touch my x-axis, right here, this little minty green point. Well, here, let me change it to a better color. Yeah, we'll stick with minty green. Okay, this is a minty green point. This is where it touched my x-axis. So this is called an x-intercept. Now, as you all know, math people like to make things a little bit difficult. Some people call them a 0, some people call them a root, and some people call them a solution. All 4 of those words are exactly the same. Literally, if somebody says, what is the root? Same thing as the 0, same thing as the solution, same thing as what is the x-intercept. Okay? So do not let them get you confused. Always, always, x-intercept is x, comma, 0. The definition of an x-intercept is when y is equal to 0. Always, okay? So let's go ahead and take a look at another one. So here at this orange point, I have what is called my y-intercept, okay? This is also my b in y equals mx plus b. So whatever number it touches on the y-axis is my letter b in y equals mx plus b. This always looks like this, 0, comma, y. Always x equals 0. So if I'm solving for x-intercept, y-intercept, whichever one, I plug in the opposite one as 0 to solve for it. So if somebody said, your equation is blah, 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 what is the x-intercept? Everywhere in that equation I see a y, I change it to a 0, and then I solve for x. If somebody said, what is your y-intercept? I would say, okay, everywhere in that equation, I'm going to change it to an x. Change my x to a 0, and I'm going to solve for y. Okay. So, just so you guys understand, the easiest way to graph a line is to always start at this point, y, because all the different forms of the linear equations that we've seen before, standard form, point slope form, we could do excited move, great divide, and from point slope form, we could do a couple of rearranging things to get y equals mx plus b. Y equals mx plus b is a great equation to start with because that b value always tells us a point without having to plug anything in. So for example, if we have y equals 2x plus 5, 5 is going to be where I start, okay? Always my starting point, always. Now, the great thing about float is this tells me where to go. If you change it into a fraction, the top part tells you why do I go up or down. Bottom part tells you right or left. All right, so that should cover mostly everything. Let's go ahead and get into the day's lesson. All right, so graphing linear functions. Okay, let's go ahead and get back to red. So, again, just as a refresher, my x-intercept is the same thing as a 0, is the same thing as a root, is the same thing as a solution. All four of those words are exactly the same. Okay, so when given a function, we can substitute any value into x to determine y. This particular x and y pair represent a point on a graph. Y-intercept is where the line crosses the y-axis. The x-intercept is where the line crosses the x-axis, which is also called a 0. F of x, g of x, h of x, etc. all refer to y. We graph lines using slope-intercept form. Which is y equals mx plus b, where m the slope, and B is the y-intercept. Okay, so let's take a look at two examples. So first one. Now, here they're asking us to deal with f of x equals 4x minus 8. So, traditionally, what people would have been taught is I plug in my -1, x equals -1, into my equation. And I would end up with a y point, correct? So, now what I can do is I can say, all right, I can go ahead and keep plugging all these in and spend all day doing that, right? I could also put it in my calculator and do the easy way and cheat a little bit. That's okay too. But remember what I said last time. This slope is going to tell us how much this is moving. Now, the other great thing is that this guy, my y-intercept, is where x equals 0. This guy. So without even looking, I know that this should be -8 because whatever this number is what my y value is at x equals 0. Now, notice an interesting pattern here. -12 to -8. I added 4. Every single one of these is going to jump plus 4. If that had been a -4, it would have went down 4. Okay, so 4. -4, 0, 4, 8, 12. All right. So I got all my values in, okay? So I could go ahead and plot them out on the graph and all this other fancy stuff, and it would take me forever to plot all these points. Okay, I'm already tired just thinking about it. So instead, I'm going to show you the easy way. So my equation was f of x equals 4x minus 8. Okay, first thing, let's identify the pieces. What is the slope? So slope, that's that guy. My y-intercept, okay. So 4, -8, x-intercept and 0. Those are the same thing, but that's not in the equation. So first thing I'm going to do is I'm going to take my slope, okay. I'm going to write it out over here to the side, my slope. Now, sometimes there will be a fraction, sometimes there won't be. Either way, we got this. So this one is not a fraction. So let me ask you a crazy question. 4 divided by 1 is still 4. So I can actually write 4 as 4 over 1. Okay? So this top number tells me plus or minus y. Bottom number tells me plus or minus x. So this means up, down, right, left. Okay? So that means 4 in the positive direction for y would be 4 up, and 1 in the positive direction to x would be 1 to the right. Okay, so let me write that out in a more general form. Slope is difference in y over difference in x. This tells me positive up, negative down. This part tells me positive to the right, negative to the left. Okay, so let me go ahead and graph this super quick. All right, so first thing I look at is my y-intercept. So I'm going to look for it on my y-axis. Okay, so there's -8. I put a dot there, and now I'm going to look at my slope. It's 4, so I'm going to change that in my mind to 4 over 1. That's going to be 4 up, 1 to the right. So 1, 2, 3, 4, 1 to the right. And I keep repeating that pattern over and over. And I'm going to do it until I run out of graph. Okay, so now I'm going to go and I'm going to look back at my y-intercept. The thing is, I still have a little bit of graph over here. I want to know where that line is going to go. So in the opposite direction, I do the exact opposite. 4 down, 1 left. 4 down, 1 left. Okay, so I have all my points. I'm going to go ahead and connect them. I'm going to put these arrows for any concerned parties so they know that this line is going to go on forever and ever. All right, now let's go ahead and analyze this. So I'm going to go ahead and look at it, and I see here it's touching the x-axis, and it looks like it's touching it at 2, 0. So my 0 is located at 2, 0. Okay, let's do the same thing over here. Wait a minute, they're really playing me with a standard form. I don't use that. I need something that looks like y equals mx plus b. Well, easy enough. This standard form, all I have to do is remember exciting move, great divide. Okay, so I'm going to rewrite my equation over here just to give me a little bit more space. Exciting move. Noticing I'm writing my x in front of great divide. All right, so now I have something. Okay, so first thing, I want to identify which one of these is my y-intercept. It is 4, the number by itself. That is when x equals 0. That tells me 0, 4. I look at my chart. Here's 0, 4. Right, so now that I know my y-intercept, I'm going to go ahead and write that in. Okay, so I have that there. Now I'm going to go ahead and ask myself, all right, how do I get these other points? Because this number here is going to be very difficult to add and subtract. But they made it a little easy for us by giving us things that are evenly divisible by 5. Okay, so I'm not going to complicate this by telling you all my reasoning, but instead, I'm just going to go ahead and plug them in. So y equals -4/5 times -5 plus 4. Cancel my 5s, cancel my negatives. 4 plus 4, that's 8. All right. Let's do the same thing here. -4/5 times 5 plus 4. Cancel, cancel. 0. Okay. Y equals -4/5 times 10 plus 4 equals, and over here we get -4. So if you notice, if we plug in a number that's here at the bottom that's evenly divisible by that, it still skips the number at the top. So -4, -4, -4. Okay. So that was a lot going on. But again, we could do this the easy way. So first of all, what's my slope? That's the number that's touching my x, so -4/5. Now, that -4/5 is going to tell me 4 down, 5 right. Now, how exactly do I remember that? Well, the top is y, bottom is x. Y in the negative direction goes down here. Y in the positive direction goes up here. X in the positive direction goes here, out to the right. X in the negative direction goes over here to the left. Okay, y-intercept, the number by itself, 0, 4. What is the x-intercept? I don't know yet, but let's go ahead and graph this. So I'm going to say y-intercept is located at 0, 4. And my slope is 4 down, 5 to the right. So 4 down, 5 to the right. 4 down, 5 to the right. Okay. Now I'm going to go back to my y-intercept, and I'm going to do the opposite because I have all this graph out here. So 4 up, 5 to the left. And I ran out of graph, so let's go ahead and put in our line. All right. I'm going to put my arrows just in case anybody's worried or concerned. My line is going to stop. I'm going to look at this. I see an x-intercept located at 5, 0. 0 is located in the same exact place. Okay, so now that we have that, I want you guys to go ahead and take a look at this. All you're doing is identifying each one of these. We're going to pull our answers next time. Thanks so much for paying attention.